Hi, this screencast is on significant figures. So just to let you know, from here on out, I abbreviate the term significant figures with the term sigfig. So get used to hearing that vocabulary. So let's start with the definition of a significant figure. A significant figure in a measurement consists of all the digits that are known with certainty plus one final digit, which is somewhat uncertain or estimated. Term significant does not necessarily mean certainty. So let's take a look at our visual here where we have an ink pen that we're measuring. And so we can see that the ink pen goes past the 4 centimeter mark on the ruler, but it doesn't go to the 5 centimeter mark. We can further measure that the ink pen goes past the 4.7 mark on the ruler, but it doesn't quite make it to the 4.8 mark. So our answer is going to be 4.7 plus this little extra, so either 4.72 or 4.73 centimeters. That last digit, the 2 or the 3, is our estimated value. So how do you look at a number and determine the sig figs that are in the number? You want to start by asking yourself, is there a decimal present? If a decimal is present, you want to think about starting on the Pacific side. So the decimal is present means Pacific, and you're going to count the number from left to right, counting all numbers from the first non-zero. So we start at the Pacific side of the number and we work our way across the country. If, on the other hand, our digit has no decimal, so the decimal point is absent, then we start on the Atlantic side, Atlantic for absent. So we're going to start at the Atlantic side of the number and we are going to count from the right to the left. And we're going to count all numbers starting from the first non-zero number. So we start on the Atlantic side of the number, and once we hit the first number that is not a zero, we continue counting across the country until we get to the end of the number. Let's take a look at some examples. How many sig figs are in each of the following measurements? Well, if we take a look at A, the decimal point is present, which means we're going to count the number from left to right. We're going to start at the first digit that is not a zero, so that's the 2, and we're going to continue counting the whole way through the number. So we count the 2, the 8, and the 6, and we see we have 3 sig figs. In example B, our decimal point is present, so again we count from left to right from the Pacific side of the number, starting to count at the first digit that is not 0, which is the 3, and we count all the way through the number. So we count the 3, the 4, the 4, and the 3, which gives us 4 sig figs. Continuing with our next example, we have 910. There is no decimal point present, so the decimal point is absent. That means we're going to count from the Atlantic side, starting at the first number that's not a 0. So we can't count the 0, we start counting at the 1. So we count the 1 and the 9, and we see that we have 2 sig figs. And the next digit, the decimal point is present, so we count from the Pacific side to the Atlantic side, starting at the first digit that's not a 0, so that's the 4, and counting to the end of the problem. So we count the 4, the 6, the 0, the 4, and we get 4 sig figs. And finally, our last example, we have a decimal point present. We count from the Pacific side to the Atlantic, starting at the first digit that's not a 0. So we count the 6, the 7, the 0, the 0, and the 0, and we end with a total of 5 sig figs. Now let's take a look at how we solve math problems with sig figs. When you are adding or subtracting, the answer has to have the same number of digits to the right of the decimal point as there are in the measurement with the fewest digits to the right of the decimal point. However, when you are multiplying or dividing, the answer can have no more significant figures than are in the measurement with the fewest number of sig figs. Let's look at some sample problems to see how this works. If I ask you to take 5.44 meters and subtract 2.613 meters, the first thing we want to do is look at the number of decimal places in each answer. So in 5.44, we have 2 digits after the decimal point, and in 2.6103, we have 4 digits after the decimal point. Now I'm going to actually solve my problem. So I take 5.44 minus 2.6103 and I get 2.8297. I want to round this answer so that it has the same number of places after the decimal point as my measurement with the fewest number of places after the decimal point. So I want to have 2 decimal places in my answer. That means I need to look to the 9 to decide how I'm going to round. So since my next number is a 9, I'm going to round my 2 up to a 3, so my answer will be 2.83 meters. And when I'm multiplying and dividing, it's similar. The first thing I want to do is take a look at how many sig figs does each number have. So here my decimal point is present, so I'm counting from the Pacific to the Atlantic. I've got 2 sig figs. 15.82 also has a decimal point present, so I'm counting from the Pacific side of my number to the Atlantic side, and I have 4 sig figs. Next I do the math, so 2.4 times 15.82 gives me 37.968. I want this answer to have the same number of significant figures as the least significant value that I started with. So that means I need to have 2 sig figs in my answer. So I'm going to look at the next number to decide how I round, and that's the 9. So that means I'm going to round my 7 up to an 8, and my answer will be 38 grams per milliliter. Now, how does this work with conversion factors? We just want to remember that with conversion factors, there is no uncertainty because it's an exact conversion. And most exact conversion factors are defined quantities. What does this mean? Use the following rule of thumb. Whatever number of sig figs you start with in the problem, that should be the number you end with when you're converting. So you don't worry about how many digits are, how many significant figures are in each conversion factor. Look at what you started with, what the problem gave you, and then end with that same number of sig figs. If you have any questions, please make sure you write them down. Sig figs can be pretty confusing, but we're going to work on a lot of practice problems, so hopefully we can resolve any of those issues pretty easily. But make sure you write down questions and ask them of Mrs. Benke.